Okay, let's draw out a cubic tangle. Let's describe what a cubic tangle is and what its purpose is, and get an idea of what these messages look like. So I have a cubic tangle is a directed acyclic graph. Oops, acyclic. Or DAG for short. It consists, a graph consists of vertices and edges, where a vertex has some data associated with it, generally. Sometimes it's only structure, but generally a directed acyclic graph has data associated with it. The IOTA tangle uses a bivariate or two-edge directed acyclic graph. The way that it is directed and acyclic is that the vertex edges actually are hashes of other vertices. HVX, and I'll say HVY. So these hashes of other vertices, Liz, focus again. Please focus. Oh, I don't mind so much. So these hashes of these other vertices are part of the data blob that defines this vertex. So it's included in that vertex, and we'll call this vertex Z. And the hash of vertex Z includes hash of VZ includes the hash of the VZ data. I'll call it data Z, DZ, hash D sub Z, collated with hash VX, collated with hash VY. And all of that makes up the hash VZ, which means that it is tied to HVX and HVY and places it in a cryptographically secured directed acyclic graph. The properties of this hash function are such that it should be one way. Such that given HVZ, you could not go back and create, you could not look at HVX and make a second HVX. That's not one way, that's also collision resistant. So long as it has one-wayness and collision resistance, any hash function should be sufficient, and it just has to be commonly used by all of the parties. Okay, so this is a vertex. This is the IOTA case. The cubic tangle case is a directed acyclic graph of unlimited vertices. I'll put ... to represent that there can be any number of them, and ... to represent that this could continue HV sum of the collated sum of all hashes that are being referenced by the definition of our zeta vertex. This is the type that we use in Qubic. In order to understand why we do it in Qubic with any number allowed and we don't do any number allowed in IOTA, one must understand that IOTA has unbounded participants. We'll say unbounded voting participants. And their identities are unknown, necessarily. So it's anonymous. And that means that when in IOTA's case, people are voting on things, they could grow the graph with, if it were any number, it would take any number to grow. Whoops, that's ugly. And it would take 1 to shrink. And this has network properties that are not advantageous to a mesh network such as what IOTA is intended to operate in. It makes a bottleneck for synchronization. Qubic, on the other hand, has bounded participants. And it operates on as a virtual graph in a network. So it's not necessarily concerned about those network properties because it expects that it's going to live in a place where either the network is homogeneous or it takes care of that problem for it. So a committee is first started by an announcement of the committee, and that is the first vertex in the Qubic graph. It's like a Genesis vertex. It references nothing. It has no edges going out, or you could say that it references null. After the announcement is made, then any number of participants seeing the announcement will begin to publish resource tests. And they will reference that announcement directly. First ones will only have one edge because they may not see each other create the other edges. Subsequent ones, maybe RT4 saw RT1 and RT2. It would point to both of these. Perhaps RT5 saw 2 and 3. So it's going to have 2 perhaps RT6 saw all of them, all of these ones, but none of these. It happened simultaneous to the other ones. Just happened to see all of them. So this is an example of how it could be any number, and then in the next phase you could have RT7 sees all of these, and it collates them all into a single point in that graph, from which that would be necessarily a bottleneck, but we presume that it exists in a network which already has its own synchronization capabilities. And this is the only portion during which it's unbounded. So this will go on for some amount of time, the resource tests, and they will just reference all the resource tests that they see which are not yet referenced. We call those vertices which have no reference tips. A vertex with no incoming edge. I think it needs something to focus on. That looked like it helped. So that's what a tip is. And let's see. So let's say that we at some point in time resource tests. These 3 resource tests are final tips that we see. We'll just call them 9, 10, 11, and then a processing phase begins. And the processing phase is understood by each of the devices of their internal clocks when they've reached that point. They count from the start time of the other clock, and once they reach that other clock's time plus some amount, they start their processing. So they will begin processing XYZ, or it's also possible that they just wait and they do no publishing because there's nothing to publish as of yet, because we just formed a new committee, and the new committee has no assignments yet. One of the new assignments that could be made by the committee is a proposal to to change the metadata of the committee for the next processing phase, or for the next epoch. Epoch spelled E-P-O-C-H. For the next epoch, so a proposal to modify I'll say proposal, I'll call it modify for metadata. Metadata proposal 1. Maybe someone else makes a metadata proposal 2. And they're going to reference all of these resource tests so they can see that are valid, and valid meaning the time that they arrived. And maybe this one decides that that one's not valid, for instance. But others could override that decision and just reference it anyway. So upon this, we're going to have a bunch of people start to, this is something that they can start voting on, or they could choose to not vote on it, say that they don't like either proposal. This requires either some local intelligence to be written for the node, or it would require that there is some interaction with the maintainer of the Oracle machine. So they might pick one of these, or they could pick both. And if they are, if each of these rules are not incompatible with each other, then both could be adopted. Otherwise, it's possible that this could be the beginning of a split. It doesn't matter. But let's say that it's the beginning of a split. We have a bunch of votes on these. So someone will see this. They'll publish. They'll publish a commitment. They'll reference it anyway, but and they'll reference this one as well because they saw it happen. They'll publish maybe H. They'll sign in. I'll do sign with a red here just to indicate that it's signed by that participant. Assigned hash MP1. And someone else might publish a signed hash of MP2. And it's going to reference both of them. So this can go on, and if a quorum is reached. And that's another metadata that could be set for the quorum is, or for the committee is the threshold for changing the metadata of the committee. So this threshold for the committee modification will, we could say that it would be 2/3. That seems to be a common one that's popular among congresses and whatnot. You could even say that it's 100%. To say nothing changes without unanimous vote. Any of these things are possible, and any of them is valid. They could make it weak and make it 1/2. 1/2 plus 1/2 plus 1 vote, or any amount of weight would be the minimum amount to decide on that. So upon this, we see this, and we see there's a second way that people could vote on this, because we have not only the participants in the committee, but we also have the consumers of the committee's results. So the consumers will perhaps reward the committee participants, the oracles who are publishing in the subtangle, which has voted on MP1. If they're mutually, if these two are incompatible, if MP1 and MP2 are incompatible, so when a threshold is reached, then someone will publish I'll do it in red since I was in red. Someone could publish essentially an announcement that we'll say, in this case, since this is on the bottom, that MP2 succeeded, and that everyone decided that MP2 is great in that subtangle. We reached our requisite 2/3 voting weight, and they'll publish a change of the MC2, which might be the hash of MP2 and some metadata to indicate that, see, we notice that this is a distinct subtangle, and if MP1 is also reached and they publish MC1, then these two would become, if these were incompatible, they would become, these two subtangle tips would be incompatible with each other, and the participants would have to begin, if they were publishing commits and results on computations, they'd have to begin publishing them in both, or otherwise dependent on how the program is written. And we'll say commit copy 1. Commit carbon copy of commit 1. They might do this. It's possible. It's also possible that a program is written such that it tells them to publish this part of a result over here and this part of a result over there. And this kind of thing would indicate to us that we have some splitting of responsibilities, for example. So it's not always a bad thing to have these split. But this is really, all that voting could happen independent of the arrival of an actual job. But let's say that we get an actual job. So we have n number of processing phase sites or vertices that are published over here, and someone publishes a request. Or rather, we'll call it a Qubic, because that's what we call it. A Qubic is kind of what we call a unit of computation or a program. So someone publishes a Q, and that Qubic might have some metadata associated with it about rewards. That might be in the format of a program for a client consumer to run to consume the results of these. That would perhaps have built-in metadata that would say, hey, if I'm interested or if I'm following and consuming this thing, then I'm going to pay, 50 cents for this result. That's the type of thing that could be put into that program and could indicate to the participants that they might want to at least give it a try. Regardless of that, it's likely that participants, the oracles, are going to pick this program up and start running it in small increments. We presume that all programs are run in small increments. So we'll call that Qubic 1, and the participants have the Qubic 1 contains a program for the oracles to run. It contains a program for consumers to run, optionally. That's essentially enough for them, but it could contain more or less. There could be other metadata associated with it that could be published, but that's essentially it. It could also have a signature associated with it for the publisher of that Qubic to decide, I want to change the Qubic in the future, and it would give them a way of doing that. So the oracles see that. They start publishing commits when they have some output given by that program. They'll start publishing a commit, and when there's, with it's signed, we'll say that's signed by Oracle 1, and this one is also publishing the same commit. When there's enough of these commits, then someone is going to reference the subtangle that reveals the value of that. These votes are the primary part of what is valuable to the oracles. If they get included in the in this subtangle of a value reveal, then the consumers of these oracles results are going to be be more inclined to give rewards to these oracles because they were timely and their processors were fast or whatever. But nevertheless, they made a decision in time that the consumers liked, and this is going to, the publisher of this value reveal is going to be incentivized to pick some minimum. It's likely that they're just going to pick everything, but they want to be timely on their picking of these commits such that they don't have to include everyone. Whatever the minimum of 2/3 to 1/2 or whatever is defined in here, this could define it, is going to be what's going to tell them what to reveal, or when the earliest they could reveal is. They want to reveal that as soon as possible. This goes on, and this process repeats for as long as there are two conditions met. One, the oracles are satisfied, and two, there's data or events to trigger this. So it could continue on and on and on and on, and it could be the type of thing that could be done in this. It could just be reporting a reflection of the Bitcoin blockchain. So these oracles could actually be a decider, an earliest decider of which Bitcoin block is the winning block. And presuming that the result of these oracles is the primary one which is accepted by a plethora of the providers of Bitcoin services, then they could use that as a zero block time confirmation. Normally they say 6 block time minimum, which is really just a rule of thumb. It doesn't actually take reality into effect, and the fact that there can often be asymmetric increases in the computational power of an attacker. But this could effectively solidify that if this is what is followed by everyone. So the processing continues until the end of the epoch. Some processing tips exist at the end, and we begin another resource test phase. We remember previously that it's possible that 2 of them had split due to difference in votes, and we can now have 2 subtangles. And they would start publishing resource tests on these subtangles. Any number of participants under whatever rule is required could publish these. And we begin a new epoch. That's all for this session.